everyone. Welcome back to the lecture series of ICSE 9th Maths. We started with the area and perimeter of plane figures and we did the first exercise, that is 17A from R S Aggarwal. Today we are going to start with 17B from R S Aggarwal, where we are going to apply the formula of triangle, rectangle, parallelogram, rhombus, every plane figure in a quadrilateral. So let's start. My name is 𝐒𝐻𝐵𝗲 and you are watching 𝐒𝐵𝗲 classes. Let's get started. The first question from 17B R S Aggarwal is, find the area of a quadrilateral, one of whose diagonal is 25 cm long and the lengths of the perpendiculars from the other two vertices are 16.4 and 11.6 cm respectively. So we draw a quadrilateral, unsymmetrical quadrilateral like this. Okay, so this is suppose the quadrilateral A, B, C and D. Don't draw a rectangle or a square or a rhombus or something. You can draw an unsymmetrical quadrilateral anyway. Okay, if you draw a rectangle parallelogram, then also it is fine. But then when they are not mentioning what type of quadrilateral it is, we will draw unsymmetrical quadrilateral. Okay, so suppose the diagonal, this BD is given. They are saying find the area of a quadrilateral, one of whose diagonal is 25 cm long. So see, BD is 25 cm long. Okay, and the lengths of the perpendiculars from the two vertices are. So if you draw a perpendicular from this vertex, okay, this vertex, this is suppose AM, the length of this is 16.4, and if you draw a perpendicular from this vertex, this is CN, this is your 11.6 cm respectively. You need to find out the area of the quadrilateral. So very clearly we can see here there are two triangles. One is triangle ABD, the other one is triangle BCD. So if you can find out the areas of the triangles separately and add them together, we get the area of the quadrilateral. So that is the concept here. We will find out the areas of the triangles separately. Okay. So from triangle, first I'll take the triangle which is up, that is ABD. ABD. Okay. Area of triangle ABD is equal to. Now the area of a triangle, the formula for that is half into base into height. Now see here, your base here is 25 cm, which is the diagonal, which is the length of the diagonal, and on that you have the height, that is AM. So we can take 25 as the base and height is 16.4. So you cancel it out to 82.2. So this is 25 into 8.2. This is centimeter square. This is the area of the first triangle. Okay. Now you can calculate or leave it like that, no problem. Next is from triangle. Now you take the triangle which is down. From triangle BCD, we can write area of triangle BCD is equal to half into base into height again. So here again the base is 25 and you can see the perpendicular on the base is this. CN is a perpendicular on the base, that is 11.6. So 11.6, so we cancel it out to 5.8. So 25 into 5.8 centimeter square. Now to find out the area of the whole quadrilateral, we have to add these two together. So I'll just erase this now and find out the area of the quadrilateral here, this side. So I'll write area of quadrilateral ABCD is equal to, first I'll write area of triangle, this is ABD, plus area of triangle BCD. Okay, I wrote the areas of the two triangles, you have to add them together. So here we are getting 25 into 8.2 plus 25 into 5.8. Now see, I did not multiply. Why? Because here I can take 25 common. So it will be 8.2 plus 5.8. So that is 25 into, this is your 25 into, you add them together, this is coming 14. Yes, 14. So 25 into 14. Now I will multiply to get the area. 350 centimeter square. So this is the total area of the quadrilateral. Okay. Let us move on to the next question. I hope everyone has written, or you can take a screenshot or write down. Okay. Pause the video and do the sum. Okay. Let me go to the next question. The diagonals of a quadrilateral intersect each other at right angles. If the lengths of these diagonals be 14 cm and 19 cm respectively, find the area of the quadrilateral. So now you have a quadrilateral. I am drawing this quadrilateral purposefully a rectangle, or it might be a rhombus, because you see they are saying the diagonals of a quadrilateral intersect each other at right angles. So when the diagonals intersect at right angles, it might be rhombus actually, because we know the property of a quadrilateral that the diagonals bisect each other or intersect each other at right angles. Okay, so this is a property of a rhombus. Okay, so A, B, C, D. This is your diagonal. This is your quadrilateral, and they are intersecting each other at right angle O. Okay, so it might be a rhombus definitely, because the diagonals of a rhombus only intersect each other at right angles. Okay, or a square. Okay, so now they are saying the diagonals are 14 cm and 19 cm. So let us consider D1 is equal to 14 cm and D2 is equal to 19 cm. This is diagonal 1, this is diagonal 2. So area would be is equal to, we have the area formula, that is half into D1 into D2. This is the area formula for a rhombus, okay, where the diagonals intersect each other at right angles. So this is 2 half into 14 into 19. So we'll cancel out this. 133 centimeter square. So this is the area of this quadrilateral. Okay. Let us move on to the next question. Question number 3. Find the area of a quadrilateral ABCD in which AB is equal to 29, BC 21, AC 20, CD 34 and DA 42. So all the sides are given. Again I'll draw an unsymmetrical quadrilateral like this. Suppose I am drawing this way. This is my A, B, C and D. So now they are saying it's a rough diagram, so don't worry about the measurement and everything. Find the area of a quadrilateral ABCD in which AB is 29. So this is your 29. BC is 21, then AC is 20, this AC is equal to 20, then CD is 34 and DA is 42. Okay, so we have two triangles over here, you can see, that is one is ABC and the other one is ACD. Okay, and all the sides are given. So we can find out the area of the triangles by Euler's formula and then we can add them together. Okay, so let us find out the area of ABC. It is, first we will find out S. S is equal to 29 plus 21 plus 20 divided by 2. So it comes 70 upon 2, that is 35. Okay, so area of triangle ABC is equal to under root S, S minus A, S minus B, S minus C. This is Euler's formula. So S is 35, 35 minus 29, 35 minus 21 and 35 minus 20. This everything is under root. So this is 35 into 6. This is 14 and this is 15. So now 35 can be written as 5 into 7, 6 is 2 into 3, 14 can be written as 2 into 7 and 15 is 3 into 5. So now we can see from here there are 2 5s, so 1 5 will come out. There are 2 7, 1 7 will come out, 2 2s, 1 2 will come out and 2 3s, 1 3 will come out. So this is 5 7, 35, 35 into 2, 70, 70 into 3 is 210. 210 centimeter square. This is the area of ABC. Yeah, so now we'll find out the area of ACD in the similar pattern. So area of triangle ACD. So first we'll find out S, and S is equal to now 42 plus 34 plus 20. 42 plus 34 plus 20 upon 2. So that gives me 96 upon 2, that is 48. So area of triangle ACD is equal to, now your S is 48, so this is 48 minus 42, 48 minus 34 and 48 minus 20. Okay, I'll have to rub this part, otherwise I'll not be able to write it. So here I'll write down one more step here. So this is 48 into 42 for 6 into 14 into 28. Okay, so I'll rub this part. I'll draw the rest part here. So it's coming 48. 48 means I can write it as 12 into 4 or 6 into 2 into 4 I'm writing. Okay, 6 into 2 into 4. This is 48. Okay. Now this is 6. I'm keeping it as it is because there will be 2 6 now. 14 is I'm writing as 2 into 7 and 28 is 4 into 7. So now see, I did not write the prime factors of everything because I'm just trying to pair them up. Okay, you can also write the prime factors. 6 into 6 is 6. 2 into 2, there will be 2. There are 2 4s, so 1 4 will come out, and this 2 7, 1 7 will come out. So 6 into 2 is 12 into 28. It is 28 into 12. So this coming 336 centimeter square. So now we got the areas of both the triangles. Now just we have to add them together to get the area of the whole quadrilateral. Okay, so I'll just rub this part. I'm writing it here. It is enough space. So therefore, the area of quadrilateral ABCD is equal to, you can write down that area of ACD plus area of the other triangle, and then you can put, I'm directly writing the values now, 210 plus 3, 3, 6. So that will give me 6, this is 4 and this is 546 centimeter square. So this is the final area of the quadrilateral ABCD. So let's start with the next question, that is question number 4. They are saying that find the perimeter and area of a quadrilateral ABCD in which AB is equal to 9 centimeter and AD is equal to 12 centimeter, BD is equal to 15 centimeter and CD is equal to 17, and they are given that CBD angle is equal to 90 degree. So here CBD angle is equal to 90 degrees. So this angle is 90 degree. That means we can get this angle's area, this triangle's area by doing half into base into height. Since it is 90 degree, so this can be considered as a height and this can be considered as a base, or vice versa, anything. So first of all, we have to find out the value of BC by Pythagoras theorem. Okay? So write down from triangle BCD, applying Pythagoras theorem, PGT, that is Pythagoras theorem, BC square is equal to hypotenuse square, that is 17 square, minus the other side square, that is 15 square. So now this is your a square minus b square. You can either do a plus b into a minus b, or you can find out the square and subtract it. Okay. So I'll do it by a plus b into a minus b. So 17 plus 15 and 17 minus 15. Now 17 plus 15 will give you 32, and this is 2. 32 into 2 is 64. Therefore, your BC will be equal to root of 64, which is 8 centimeters. So I got my BC. Now I'll just find out the area of that triangle. Area of triangle BCD is half into base into height. So base I am considering as 15 and the height I got as 8. So this will be 60 centimeter square. So I got the area of this triangle, this right angle triangle. Okay. Now for the other triangles, we can see all the sides are given, so we can get the area by Heron's formula, and then we can add the areas together. So let us find out the other triangles area by Heron's formula. So from ABD, S is equal to 12 plus 15 plus 9 upon 2. So that is 46 upon 2, that is 23 centimeter. Therefore, area is under root 23, 23 minus 12, 23 minus 15 and 23 minus 9. Now, this is 23 into 23 minus 12 is 11 into 8, that is into 14. Just I'll add it one more time. Okay, this is 32, sorry. This is 32. I'll rub it, this has become wrong. I'll do it again. This is 36 by 2. 36 by 2. 15 and 12 is 25, 27. 27 plus 9 is 36. 36 by 2, that is 18. So the area would be equal to S, that is 18. 18 minus 12, 18 minus 15 and 18 minus 9. So that is 18 into 6 into 3 into 9. So I can write 18 as 9 into 2, 6 as 2 into 3, and then 3 is there into 9 is there. So from 2 9s, 1 9 will come out, 1 3 will come out and 1 2 will come out. So it's 9 3 27 into 2 54. 54 centimeter square. So this is my 54 centimeter square. 54. This is 54 centimeter square. Okay. So the previous triangle's area is your 60 centimeter square, and this is 54 centimeter square. So togetherly it will be 4 and 11, 114 centimeter square. So we can just write down I'll just write it here. Yes. So area of quadrilateral ABCD is equal to 60 plus 54, that is 114 centimeter square. So this is our final area of the quadrilateral ABCD. Okay, let us move on to the next question. Question number 5. Calculate the area of a quadrilateral ABCD in which AB is 24 centimeter, AD is 32 centimeter, BAD 90 degree and BC is equal to CD, that is 52 centimeter. The diagram is given. The diagram is like this. This is A, B, this is C and this is D. This is 52, 52, 24 and 32. So you can see this angle is, BAD angle is 90 degree, that means this is a right angle triangle. So we can find out the area of this ABD by half into base into height. Also by applying Pythagoras we can find out the hypotenuse, and once we get the hypotenuse then we can find out the area of BCD by Heron's formula. Okay. So first we'll find out the hypotenuse, that is BD square, and directly writing you have to mention that by applying Pythagoras and everything. BD square is equal to AB square plus AD square. AB square is 24 square plus 32 square. 24 square is 576 plus 32 square we need to find out. 32 into 32. 1024. 1024. So 1024 plus 576, it's coming 1600. 1600. Therefore, your BD will be root of 1600. That is 40 centimeter. So we got this as 40. So now we can find out the area of ABD. So I'll not do the sum now. You can do it. Area of triangle ABD is equal to half into base, that is 24, into height, that is 32. So 2, this will get cancelled. 12 into 32 centimeter square. So this way we can get the area of ABD. And now the area of the other triangle, area of triangle BCD, we can get it by Heron's formula. Heron's formula. Okay, we have done Heron's formula many times, so you try this sum, and then finally what will happen is the area of the entire quadrilateral will be sum of the two areas of the two triangles. Okay, you have to find out the area. Yes. Acha, in the previous sum we had to find out the perimeter also. I'm so sorry, I forgot to do that. In the previous sum, the perimeter also. So I'll just write it down. The perimeter here. Perimeter of the quadrilateral ABCD is sum of all the sides, so that is 12 plus 9 plus BC, and BC we got as 8, I guess. Yes, it was 8 and plus 17. So when you add all of them together, you get the perimeter of the quadrilateral. Okay. So today in this session we have done the question till question number 5 of 17B exercise. Another, there are actually 13 questions in this exercise, so we'll keep on doing it in the next class. So if you feel these videos are beneficial to you, please subscribe the channel and press the like button, and stay tuned. Thank you so much.